I was in Hong Kong a little more than a year ago when some bombshell news emerged that has profoundly changed the horizons of possibility for genetic engineering in the human species. This moment was long awaited, uh, at least since the 1950s. Scientists have been talking about changing the human condition by modifying our DNA. I was jet lagged. It was a surreal scene. I was staying at a hotel. It was called the Le Méridien Cyberport Hotel. The sort of French accents here in East Asia. You know, Hong Kong's a place that inherits histories of European colonialism, but also uh, financial and technological innovation. There was a guy staying in the hotel named He Zhanghui, and a bunch of us from around the world had come together for this international summit on gene editing. This wasn't the first summit. The first one happened a few years earlier in Washington, but then we were just talking about everything in the abstract. I'd been invited to Hong Kong to speak on an ethics panel to talk about whether or not we should use this new tool called CRISPR-Cas9 to fundamentally alter the DNA of the human species. This news just suddenly emerged. A birth had happened a few weeks ago. We'd all sent in our PowerPoint talks and had our prepared notes, but had to do a lot of homework to catch up really quick to figure out what had just happened. I checked into my room, this luxury suite, courtesy of the National Academy of Science, overlooking this forested hill, and I opened up the internet, hunting for sources of reliable information. A few hours before, some videos had been posted to YouTube announcing the birth of Lulu and Nana.
Two beautiful little Chinese girls named Lulu and Nana came crying into the world as healthy as any other babies a few weeks ago. The girls are home now with their mom Grace and dad Mark. Grace started her pregnancy by regular IVF, with one difference. Right after we sent her husband's sperm into her egg, we also sent in a little bit of protein and instruction for a gene surgery.
And the videos announcing their birth claimed that they were healthy babies, just like any other, that had just a very small change. Dr. He claimed that he had changed the DNA for the gene called CCR5. This is a receptor that is like a door that lets HIV viruses get into the cell. So I'm telling this story at a moment in time when a virus has upended the modern world. It's at a time when many of us are alone in our rooms and reflecting back just to, a little more than a year ago. It's a really different moment. Here's a moment when the promise of science and technology seemed limitless. It seemed like we were entering into this new era of an ability to change what it means to be human. I'm going to unravel this particular experiment, departing from this scene in a hotel where we were all struggling to figure out what had just happened, to point out that Dr. He is certainly not alone in doing this kind of experiment. But really, I think his experiment opens up a lot of fundamental questions about human identity. Should we use this tool? Should we use CRISPR-Cas9 to alter our biological heritage? We can think about that in a lot of different ways. Really, species are sort of artificial constructs, right? We could take things from other forms of life and introduce them to our own genomes. What would be the implications of that? But also, as an anthropologist, as someone who's often finding myself on the other side of debates about human nature when I'm talking to biologists, the classic nature-nurture conversation, we have genetic determinists on one side saying that we can reduce all the important things about human behavior to DNA sequences. And then, my field, ever since Margaret Mead published Coming of Age in Samoa, anthropologists have been thinking about ways that language and culture and ethics and values really shape what it means to be human. So at this moment where there was international outrage about this experiment, outrage because there were echoes here of earlier eugenics movements. Eugenics literally means good genes. And we saw all kinds of experiments in the 20th century, whether that's the death camps of the Nazis or the sterilization programs in the United States that targeted immigrants, the feeble-minded, homosexuals. We as a society decided that eugenics, at least using those earlier 19th and 20th century technologies of sterilization, of genocide, collectively we've decided that that's not something we want to do. But, are these tools potentially going to open up a new era of eugenics? And, if we are going to start tinkering with DNA, what are the philosophical implications of these experiments? So at Hong Kong, we all gave our talks. 1.8 million people watched in real time as we talked about CRISPR, as Dr. He waded through the technical details of knocking out this particular receptor in these two baby girls. And then, the real action was happening behind the scenes. So sitting in the bar of this hotel, there was a committee of 13. And, there was about 50 of us who were invited to give talks. And so we were just milling around. Well, this committee of 13 decided about a statement they would issue to the world. And, we're all hanging out in the bar, free drinks and nibbles, Nobel laureates, David Baltimore coming in and out. Jennifer Doudna was there. She's one of the people who showed us how to use CRISPR to alter DNA. So collectively, this group of 13 decided that similar experiments should continue, that we should be able to use CRISPR to modify the germline of the human species. The germline basically means that those are the cells we pass on to the future. The somatic cells are the cells in our body. And up until that point, there had been many gene therapy experiments that had been met with limited success. So each one of our cells, we have about 34 trillion of them, has its own set of DNA. It's its own, set of chromosomes bundled together in a nucleus. So, if you try to roll the dice 34 trillion times, first of all, you're not going to hit all those cells. And second, you're more likely to make damage or make an error when you try to alter the DNA. So in part, this statement from the Committee of 13, insisting that similar experiments go forward, that was driven by a technical fact. If you make a change in an embryonic cell, at a single cell stage or maybe at the 2-cell stage after the DNA has kind of settled down and you have a stable individual, that's a more powerful technical project. Theoretically make a change in those cells and it happens, it's something that's a stable part of that human that emerges from those embryonic cells. But, I think there's clearly something more fundamental at stake than just a technical question. Clearly the international outrage that emerged from this experiment. You had CNN calling the experiment monstrous. I think if we step back from that a second and interrogate what might be the monster here, are they talking about these children as being monsters? I've had colleagues argue, we have to think about the most vulnerable in these kinds of experiments, and those are the people that result. How do we treat them? Do we treat them as monsters? Or is Dr. He being talked about as a monster in this kind of way? There's a lot of colonial literature that expresses deep anxiety about Asian Oriental scientists stealing Western knowledge and endangering civilization. There was a series of British novels. Dr. Fu Manchu in 1912 debuted in these novels where, in the words of the novelist, this evil Oriental genius takes knowledge that's not rightfully his and uses it in an inappropriate way. So in investigating this story as an anthropologist, while I'm thinking about these fundamental questions about human nature, I'm also paying attention to how racism is playing out in this story and what Edward Said calls Orientalism. Do we have certain assumptions about Asia, about, sort of the West and the rest that are coloring this story? How would this story look different if it was a white scientist in Europe? And in the course of this book project, I met many white scientists who are working towards those same basic goals. So if we rewind again to some of these fundamental philosophical questions, there's an important book that was published in 1958 called The Human Condition by Hannah Arendt. And at that point, satellites are launching into space for the first time. There's a proliferation of nuclear weapons that threatens life on Earth. But also some of the very early dreams, as Watson and Crick have described the DNA double helix, people are talking about making what she terms future man. Should we recombine human elements in a test tube to make a superior human being? So Hannah Arendt was a survivor of the Holocaust. She was tuned into the ways that eugenics, again, good genes, could have profound and catastrophic consequences on humanity. And she was worried. She was worried, she had no doubt that scientists at the time could destroy life on Earth. She saw the proliferation of nuclear weapons with satellites in space. This was before the Reagan era Star Wars, but this is at a moment where planetary survival is threatened by the scientific project. So her question is, how do we want to use these tools that are at our disposal? Do we want to destroy life on Earth? I think the answer to that question is easy, even as during the Cold War, there were all kinds of nuclear proliferation projects, nationalist projects that were, creating a planetary situation of endangered peril. But at the same time, she saw the seeds of these other nationalist races, the race to be first, with famous scientific discoveries. And this is what Dr. He's project ultimately embodied, There was an intense speed to his research. He wanted to do it quickly. He wanted to do it before anyone else. He did it in secrecy. And this is actually kind of how it's been done throughout histories of science. So in 1958, with this book on the human condition, in one register, Hannah Arendt was worried about IVF. It hadn't been described as that yet, in vitro fertilization, life in glass, the fertilization of, test tube babies. She was worried about that. And then that came much sooner than everyone anticipated. So in the human condition, she says, within 100 years, we will see future man. Future man being the recombination of, elements of people that have good genes and also life in a test tube. But what we found with the birth of Louise Brown, who was born in England, again, highly controversial. Everyone from the Pope on down to, random people condemned the birth of Louise Brown. Her parents received threatening letters, calling into question their choices, calling this baby a monster, using a phrase that was later bandied about and applied to Lulu and Nana, this idea of a Frankenbaby, this monstrous creature. And Louise Brown's life, really, it's not been miraculous, if you look at it. She if you go on the internet and search for Louise Brown, she's got a website. She does do public speaking, but her day job is basically at a shipping company. She's a working class woman in the United Kingdom. Her whole lifelong struggle, in the words of a friend and colleague, Sarah Franklin, has been to be normal. She doesn't want to be seen as exceptional. And she was celebrating her 40th birthday the year that Lulu and Nana were born, with a book tour. And, I think her life story shows us that these technologies that we might have thought of as being revolutionary, profoundly disruptive, might not actually change us in some kind of fundamental way, like returning to that question of human identity. But I want to get to the subject of my talk. The title is Remaking Life with Shenzhen Speed. So right after the summit in Hong Kong, I traveled to mainland China, and just across the border, across a bridge, there's a bay, there's tunnels that go under it, there's high-speed trains, there's a lot of ways to get between Hong Kong and Shenzhen, but it's the closest city. And this is a massive city. If you are watching this on a computer, if you're watching this video on your smartphone, there's a good chance that it was manufactured in Shenzhen. This city is where China opened up to capitalism, where the very first experiments in engaging with the capitalist world system were conducted during the reform and opening period. Shenzhen first crossed my radar when I listened to a This American Life podcast many years ago. There was a gonzo American journalist, someone who styled himself as a white hero wearing a Hawaiian shirt, and he wanted to investigate where his iPhone came from. The episode starts out with him asking Siri, "Where do you come from?" And she says, "I can't tell you that." So Mike Daisey went to these factories where our electronics are made. There's a company called Foxconn that manufactures most of the electronics in the world right now. So the story of Shenzhen Speed starts before Foxconn. It starts in the 1980s when skyscrapers started going up in Shenzhen faster than anywhere else on Earth. Shenzhen is a place where we had all kinds of things that were fundamental to American life being manufactured in the 1980s. Everything from Cabbage Patch Dolls to Star Wars figurines, to boomboxes, to Walkmen. These are all iconic Shenzhen products. But fast forward a little bit, you have all kinds of worker suicides. You have assembly lines running faster and faster, trying to optimize profits, people sleeping in tiny, cramped conditions. And, Mike Daisey's trying to tell this story. He characterized this city as a place where Blade Runner threw up on itself, this dystopian, techno-oriental future. So Ira Glass retracted that story. He found that Mike Daisey embellished. He misrepresented some of the core facts about Shenzhen. He said that he talked to some children who were laborers in the factory, when in fact he didn't. The fundamental facts of the story, I think, hold. There are serious labor problems. There are worker suicides at these factories that make your electronic products. These assembly lines, the construction of buildings, moves at an unrelenting speed. But in my mind, when Ira Glass retracted that story,
he missed a very fundamental and more banal fact. Shenzhen does not look like Blade Runner. In my mind, it looks like San Diego or Orlando, just with gigantic skyscrapers, some of the largest buildings in the world. So I visited one of these buildings, the Ping An skyscraper, the tallest building in Shenzhen. It's the fourth tallest building in the world. And I went to lunch with a young tycoon who was a friend of Dr. He. So Dr. He, in contrast to Victor Frankenstein, this secretive figure who worked in an attic, who was flouting some of society's fundamental norms, who turned away from his creation, ran away when this monster emerged on the table. Dr. He was very much a man about town. He was a charismatic entrepreneur. His story is less Frankenstein and more about Silicon Valley. It's more about the innovation economy and the hype and the hope that gets attached to technology. It's an American story. It's a California dream as much as it is this story of the new biotech future in China. So I had lunch with this guy, and at this point, Dr. He's in detention. If you follow this story at all, you know that Dr. He was sentenced to 3 years in prison for conducting this experiment. At the point of my visit, that had not yet been made public, but through various sources, I was able to learn about his conditions of confinement. He'd been basically taken away by security forces with very little notice at the same time he lost his job. While in Shenzhen, I visited the university laboratory where Dr. He conducted the bulk of the experiment. I also visited some hospitals that gave him ethics approval for this experiment, places where profit-driven medical enterprises, where plastic surgery, where efforts to remake race are already happening. At the same time, there's this investment in, the potential future of humanity. So this is a story of venture capitalism. This is a story of speculation, hope, and hype, and someone moving so fast that he neglected some of the basic ethical calculations that, completely were treated as, So this experiment, not only from an international perspective, but within China, was flouting fundamental norms and values. So there'd been earlier experimental work done not too far away in mainland China, altering human embryos with CRISPR. So the first experiment was April 2015. That's when the paper published. And this was in non-viable human embryos. It was working with a genetic disease, a blood disease, beta thalassemia. And in the international press, it was as if there was doom and gloom that had happened. There was international outrage. China, embryos, biotechnology. But in China, there's very different ethical calculations that sort of shape understandings of early moments of life. So in contrast to a bioethics that's grounded in traditions of Christianity, where we have politicians and right-wing activists insisting that life begins at the moment of conception. We're at a moment where fundamental rights about choice and reproductive medicine are being called into question by ethicists who are grounded in a very different, religious tradition. In China, it's a very heterogeneous field of ethics. The Cultural Revolution of Chairman Mao tried to upend religion, tried to say, we want to get past all of these superstitious beliefs. We want to do away with, all these older values and replace our norms and values with ideas about progress, technology, modernity, to do away with Taoism, Confucianism, all these older belief systems that Chairman Mao painted as sort of just superstition. But if you really talk to people today, many of those values still linger. So importantly, in the Confucian tradition, life does not begin at the moment of conception. A person emerges in the world at birth. So Dr. He saw how the world reacted to this earlier experiment. So in April 2015, a paper publishes, outrage in the international media, some scientists saying Chinese people have no ethics, making some of these same borderline racist characterizations of this work. So Mike Daisey's talking about Blade Runner, this dystopian techno-futurist scene. This isn't Blade Runner. This is a more banal, everyday reality. There wasn't some secret Chinese plot to, genetically engineer super people. There were, very hardworking scientists trying to reckon with, okay, here's some human diseases. We have new tools. Let's test them out. So since that April 2015 paper, laboratories in the United States and England have done similar CRISPR experiments with human embryos. So from Dr. He's perspective, as he was evaluating possibilities for his own research, he saw that the scientist, Dr. Huang, who did the original CRISPR embryo experiment, basically was promoted. He was recognized in international magazines as one of the most important people in 2015, after the controversy settled down, after the West caught up with this innovative experiment in China. So Dr. He thought that his experiment would be treated much in the same way. But I think one of his fundamental miscalculations is that, Chinese ethics is not simply about technological progress, modernity. There's much older values and norms that people are thinking about, that they bring to the project of science, of technology, of modernity. So for him, it was a simple calculation. It was a technological problem. He saw a way that the HIV virus gets inside of cells. He thought he could, break this receptor, prevent the virus from getting in, and protect children from a disease that people have been trying to cure for a long time. These hopes for an HIV cure are very old. They go back to this plague that, there's many, I think, resonances. This current moment of coronavirus in many ways is replicating what young gay men felt in the late 80s and the early 90s, a time when people were afraid to touch each other, a time when you didn't really know how the disease was transmitted, at least in the early years. So Dr. He saw the technological promise of this new tool, and he was situated in a community where this was the goal, a community within China, a community internationally. James Watson, the guy who took a peek at a X-ray crystallograph done by Rosalind Franklin, and then described the DNA double helix, the famous Watson and Crick. The conventional story of that scientific discovery privileges two white men, but there's really a woman in there, and her results were stolen. So Watson, in many ways, is an important figure in this story, not only because he shows up in Shenzhen, he shows up at Dr. He's university. He wasn't involved in the experiment, but he gave a public lecture as the experiment was already underway. Dr. He asked him a question. Were you thinking in the 1950s when you described the DNA double helix, were you thinking about modifying human DNA? And he said, yes, of course. We've all been thinking about this. So Dr. He followed up with another question. What should we do now that we have this capability? And Watson simply said, make people better. So during one of Watson's visits to Shenzhen, he visited this other facility. So a year before the news breaks from Hong Kong about Dr. He's experiment, I visited China's National Gene Bank. And this is a massive project. This is a facility that dwarfs anything similar in the United States. I was there for the opening ceremonies, and international scientists from around the world, including people involved in the Human Genome Project from the United States, were there. George Church from Harvard was there. Famously, Church wants to reanimate extinct forms of life. At the entrance of the gene bank stand these massive woolly mammoths, an extinct species from the Pleistocene. And George's Church's project in the States, he's enjoyed much support, but they were within this gene bank dedicating a whole new facility to bringing back extinct forms of life. So my story about remaking life with Shenzhen Speed is not just about Dr. He, is not just about this one particular experiment that erupted on the international stage, but I want to tell you today also about this broader Chinese biotech landscape. So this is October 2014 at the Chinese National Gene Bank. It's being opened by a public-private partnership. The company involved used to be called Beijing Genomics Institute. Now it's simply known by an acronym, BGI. And BGI is a big player internationally. So internationally, there's three big companies that sequence DNA. So Illumina in San Diego is probably the biggest, has the biggest market share. Thermo Fisher, also in the U.S., is another big player. BGI comes in at number 3. So they're the third largest company. So if they were making beer, they'd be like Kirin, the third largest beer manufacturer. You know, it's not an Anheuser-Busch, but it's a major player. And during the opening ceremonies, when they're kind of dedicating this facility, the director of BGI makes a profound claim. He says that this facility aims to collect. First, you know, he lays out this timeline, right? So they want to collect the DNA of every single agricultural plant. All right, not a big deal. Second, they want to collect the DNA of every single human being on Earth, which is mind-blowing, monumental. Third, they want to sequence every form of life on Earth. And this facility not only aims to read DNA. Again, here we are in October 2017. This is a year before Dr. He's experiment. Publicly, they're claiming they want to take the technologies that they've developed to read DNA to rewrite the book of life. This is the language that they're using. So they want to go from genomics, the sequencing of DNA, the interpreting of genes, situating genes within context, to synthetic biology. That is, creating organisms hybridly, you know, taking DNA and splicing it together, rewriting it base pair by base pair. So there's a lot of things going on right here, right? So this massive facility, you know, they have huge underground caves for storing frozen samples. They have massive databases. They walk me through the facility with other scientists, showing us the robots that are doing the DNA sequencing. They have everything from desktop machines that dwarf the Human Genome Project that cost $2 billion approximately in the US that sequenced the first genome. These little desktop boxes dwarf the capacity of that initial initiative. There's hundreds of machines in this room, plus robots that are sequencing even faster with a much higher throughput than these desktop machines. So I asked one of the employees about this promise, you know, that they want to collect all of our DNA. To me, logistically, that seems, you know, like there's a lot of companies out there with big goals like that. So I push a little bit. And, you know, eventually one of them tells me that in a few years, giving away DNA sequencing is going to be trivial, in the same way that Google right now gives away storage for Gmail. You know, companies are going to be offering people DNA sequences for free. So right now, if you're a researcher, DNA, you can do a whole genome sequence with BGI, this company, for $600. That's how much it costs. In comparison, Illumina, the sort of the biggest company with the biggest market share, will offer that same service for around $1,000, give or take. So they're saying, for an individual person, the company can offer this one-time DNA sequence for free. And this is different than 23andMe. 23andMe is just looking at small little snippets of DNA, something that might tell us, 23andMe, to quote my friend John Marks, is basically junk science. And that's a talk for a different day. But what BGI is doing is fundamentally different. These are whole genomes at high fidelity, meaning they're reading it at least 30 times, making sure that they got, all the A's, the T's, the G's, the C's in a row. So they say that the money is to be made not in that initial sequencing work, but in the interpretive work, in making sense of the DNA, in offering customers personalized medicine, targeted gene therapies. One of the most startling things in this BGI exhibit was not the sequencing capacity, which was huge. They'd already collected 4 million whole human genomes. It's the largest database of its kind in the world. There's other databases. There's forensic databases that police were using. And by the way, this company does have a forensic arm. So you should think carefully about which company, or if you do want to sequence your DNA, what are the risks? What are the benefits? You might find that by entering your own DNA into a database, you're subjecting yourself and your family to surveillance from forensic authorities. But that wasn't the most remarkable thing about this exhibit. They had a table in a big atrium that was like an exam table that a woman would sit on during pregnancy. But instead of a woman, there was a plastic canister and a flexible bag that looked like it might have liquid inside. And if you looked close, there was pink flesh. There was baby flesh in there. And there was a big arm reaching over this apparatus as if it were doing an ultrasound of this disembodied fetus. So that dream is also not new. There was a novel called The Brave New World. Aldous Huxley described, this is well before we have Louise Brown and IVF babies, but this dream of social conditioning of human embryos, this idea of taking the embryo out of the woman and mechanically giving birth. This is happening in the same milieu, the same technological environment where these early dreams about using CRISPR to give us good genes are being put into practice. So I think there's a dystopian way of looking at that, but to offer maybe a heterodox picture, an unexpected perspective on all of this. There's a feminist philosopher named Firestone in the 1970s who wrote a book that basically called for the liberation of women by any means possible. She was explicitly calling for facilities like this to basically take the work of reproduction out of the human body and mechanize this. She said that this would be a route to feminist liberation. Of course, there's been many thinkers since who've complicated Firestone's vision, and Firestone herself was concerned about the eugenic possibilities of reproductive technologies like this. I think when we think about eugenics, we often think about these extermination campaigns by the Nazis that have, targeted Jews, homosexuals, the disabled. Less often are we thinking about the campaigns that lasted much longer in the US, that sterilized people with physical and mental disabilities, even poor people, immigrants. I think, Firestone was attentive, this philosopher, this feminist, who was celebrating the possibility of reproducing in a mechanized way outside of the human body, she was attentive to ways that these technologies could be used eugenically. And, if we think about eugenics not as just good genes, but as this imperative to produce the best humans, the fittest humans, if you push at that really is about eliminating the disabled, is about eliminating people who might be neurodiverse, who might have non-normative sexualities, whatever norms we happen to be inhabiting at a particular moment in history. In the 1950s, these if and you have people even much later like Watson, who I've mentioned, saying that if there were technologies to identify a gay gene, mothers should be able to have an abortion. It turns out sexuality, just like intelligence, just like athletic ability, can't be reduced to a single gene or even a suite of genes. These questions become quite complicated. But ultimately, this facility I took to be not just about this projection of a future to come, but a really interesting way of thinking about technologies that are already out there in the clinic. So one of the most effective technologies that BGI already has in the marketplace, this company that runs the gene bank, they have an international presence. They're present in the US and Africa and Australia, throughout Europe. They have a prenatal testing technology. It's called NIFTY. And it's not the only prenatal testing technology that's on the market, but it's basically operates the same way as all these other tests. Instead of amniocentesis, where you do this risky procedure involving needles that could involve a miscarriage, you just take a little bit of blood from someone who's pregnant. And these blood samples will let you detect all sorts of things, from Down syndrome to other, rarer conditions, including some kinds of sexual diversity. So there's a syndrome where you have an extra X chromosome if you're a boy, XXY. This is Klinefelter syndrome, and these boys, don't have bodies that are normative. They often experience harassment as they go through puberty when other boys make fun of them. They, in many cases, aren't able to have children themselves. They're often infertile. But should they exist? People with Klinefelter syndrome generally grow up to be, tall, lanky, to have hairless bodies, to look androgynous. Do people who look like that, do we include them in the human population now, or should they be systematically eliminated? So for me, the questions posed by CRISPR are not new ones. We're already reckoning with very difficult questions about, do you choose to abort a child if you detect Down syndrome? These are very difficult choices. Like if you're a parent, choosing to live with a future of disability, choosing a disabled child, is not one to be made lightly. But many parents are choosing to do this. They're choosing to say, I can live with this. People with Down syndrome are part of what it means to be human. So for me, returning back to Dr. Hu's experiment, he was trying to help people in his mind. There's a lot of intersecting interests here, right? And in my book, I describe, the business ventures that he was entangled with, the ways that he was already trying to scale this venture up to a massive clinic, even before basic issues of safety had been worked out. In the book, I chronicle, the lives and the stories of parents who signed up for the experiment, HIV positive men, many gay and bisexual, navigating very complicated lived experiences of social discrimination. but for me, he picked an interesting target in the sense that, this particular receptor, CCR5, is one that CRISPR is well suited to deal with, right? CRISPR isn't editing. A lot of people like to talk about CRISPR as if, it's like your word processor. You write a sentence, it's not quite right, you back up a little bit, you add some more words, you might cut, you might paste, but you can refine and improve the text until it's perfect. In my mind, that metaphor is completely inappropriate. It implies technological mastery. We don't have that. What we do have is a tool that grabs a hold of the DNA double helix and breaks it, and then relies on the cell itself to repair the damage. And sometimes the damage is repaired and, you can't even tell that there was a break there. Other times you might be missing a letter or two of DNA. In other cases, you're missing thousands of DNA base pairs. This tool is better explained, in my mind, as a targeted drone strike. So you give a drone GPS coordinates, you shoot a missile, often you take out the target. But sometimes you also take out the wedding party. And sometimes your coordinates are inaccurate, so it hits a totally different site entirely. And this is how CRISPR works. And editing, drones, missiles, these are all imperfect metaphors. And what it really does is do targeted mutagenesis. In other words, it makes mutants. So in my book, I play with this idea of the mutant. It's unpredictable, it's unruly, it can't be controlled. But what Dr. He did with this particular receptor, he used CRISPR to scramble the DNA at this site so that HIV cannot get into the cells. In my mind, he picked an interesting target. I think if I were a parent, I would choose to have awkward conversations with my kids about safe sex. I would talk to them about condoms. I would talk to them about new prophylactic medicine, drugs that prevent HIV, called PrEP. If I had a child that was engaged in particularly risky sexual behavior, PrEP is a great alternative. But this age-old dream, this dream that goes back to HIV-positive activists from the late 80s, the early 90s, who've been advocating for experimental and risky ventures. In some ways, like, this experiment fulfilled those dreams. We actually don't know. So in my book, I describe the very messy reality that emerged when these two babies were born. I was able to get access to the health data from their very first moments of life, and some of the experiments that Dr. He wanted to do, like test their blood to see if it was resistant to HIV, they were never done. So we don't know if these two babies, as he claimed on YouTube, are in fact resistant to HIV. But for their parents, the men who signed up for this experiment, and there's a whole complexity here too about men and science, men making choices for their family that are putting the bodies of women at risk. This is a whole other thing that I explore in the book. But for the men, for men living with stigma, living with discrimination, that's ultimately what they wanted to get out of this experiment. They wanted to inoculate their kids against this virus, against that lived experience of discrimination. But I think ultimately they were left with a horribly tragic irony. Here we have two babies, Lulu and Nana, and now there's a third that was also born. They're not, being hailed by society as these remarkable new superhumans. The comments that emerged on social media, the media reports, everyone from The Atlantic to, again, CNN, to major established sober outlets, were hinting that these babies were monsters. So the parents wanted to liberate their children from stigma, from the possibility that they would suffer from that same discriminating treatment. So for me, that's really what this story is about. It's a fundamental question about human identity. If we change some DNA in future humans? Will they be regarded as human? As we change and transform humanity, who gets to count? Who gets to enjoy the rights of being fully human? Are there going to be more children like these kids who are going to be called out as somehow aberrant, as monstrous? Are we going to use tools like CRISPR to try to perfect humanity? Or are parents going to be able to live with diversity, to live with the unpredictability that you get when you have a child, to have this image of the perfect child, but then to be confronted with the reality of a needy, small, vulnerable human that you ultimately cannot control? Thank you.